represent the schema for the arguments for our add tool, we can associate it with the actual add tool. And the way that we do that is when we are decorating a Python function, right? So this here is a vanilla Python function. We're kind of redecorating from scratch. We're again going to decorate with the tool decorator, but now we're going to pass the tool decorator with this named argument args schema, which we will set equal to the Pydantic class that we specified above. So you'll notice because we provided all this information in the Pydantic class, including the docstring, we're no longer adding a docstring inside of the Python function. And in fact, even though we have type hints here, those are no longer required because they've been made explicit in the Pydantic class. Okay, so just to summarize, you can, and it's even recommended when creating arg schemas for tool use, that you can use Pydantic classes just like you did with other forms of structured data. And when creating that Pydantic class to represent the schema for the arguments for a tool, you can and should take care to use your docstring, to use your description fields as a form of prompting to the model about how it ought to utilize this tool. Okay, so hopefully, so let me be clear here, right, that we're discussing at length like how to create a tool, and you might still feel a little fuzzy because we haven't like given the tool to LLM to use, and so maybe there's that part is unclear. We're going to get to that very shortly. But now that you understand kind of the syntax, the process of creating a tool, we are going to have a simple exercise here where it's going to be your goal to make a multiply tool. So it should multiply together two whole numbers. We would like you to use a Pydantic class to specify the tool's argument schema. So pause the video, take care to do that, and then come back and we'll take a look at the solution together. This is just to make sure you're kind of starting to incorporate and understand and get familiar with the actual process of creating a tool. Okay, so give that a go. I'll see you in just a few minutes. Okay, so hopefully you found that very straightforward. Hopefully it's a process you feel like you could do again because you're going to be doing this quite a lot. Our solution was to, again, create an arg schema, which we're naming multiply. It's going to be a Pydantic class inheriting from base model. We're using a very similar docstring. We're saying to the LLM, use when and if you need to multiply two numbers. We have a typo in our solution. Let me fix that. And we are specifying two arguments, A and B, which should be integers. We mentioned in the exercise prompt that you should multiply whole numbers together. Of course, these could be floating point values or other. And then once again, we're indicating that these are required fields and just specifying that A is the first integer and B is the second integer. Having defined our arg schema, we will associate it with the tool decorator and actually decorate the multiply function. And now we have a multiply tool as well. So we've got two tools at our disposal now, an add tool and a multiply tool. And with that in mind, now that we've created a couple of LLM tools, we want to actually make an LLM instance aware that they're available to be used. So the most straightforward way to do this is with the bind tools method. And in LangChain, the bind tools method is available on LLM instances that support tool use. And the bind tools method expects a Python list of tool definitions. So we've already defined the LLM instance above. It's LLM. So let's construct a list containing our two tools and then bind them to the LLM instance. So here we're going to find a variable called tools, which is a Python list of our two tools, add and multiply. And now on our LLM instance, we can invoke the bind tools method, passing it in our Python list of tools. And this will return a new LLM instance, which we are calling LLM with tools. Okay, so and now we can use this LLM with tools. So to begin with, when an LLM instance has tools bound to it, like LLM with tools, we can still use it for non-tool related calls, just exactly as we have all throughout the workshop. So here we're going to provide a very simple prompt that has nothing to do with addition or multiplication. It's just asking the question to the LLM instance, who are you? And we're intentionally not using the string parser here. We're popping the content field out. We're going to look at the entire response. So looking at the response, we can see, just as we would expect from our all of our work prior to tool use, that we're getting back an AI message. The AI message has a content field. And here, if you want, you can read, the LLM articulating who it is. Okay, so as stated, the content of the response is pretty much what we would expect. So now, however, if we prompt the model with a prompt that has something to do with multiplication, right? And this is a task that we've associated with a tool that we've bound to the LLM. And just to be super clear about this, in our multiply tool, at least in our solution, you might have something slightly different that you're using. But in the doc string, we were very explicit, use when and if you need to multiply two numbers. Right? So if we now invoke the LLM with tools with the prompt, what is 1, 2, 3, 4 times 5, 6, 7, 8? Okay, if we look at the response, the first thing we might notice is that we still got back an AI message, but the content field, which is usually where we see the response from the large language model, it's empty, right? And just to be super clear about that, we can look at the response property. However, if we either drill into this full response or look here, we can see that there's a property we haven't looked at before called tool calls that now has a value associated with it. And specifically, you can see that tool calls is a list. And in this case, it's a list with a single dictionary. And the dict contains the name of one of the tools that we've bound to the model, namely multiply, as well as an inner dict called args that conforms to the args schema associated with the tool, namely two integers, a and b. And just like when we use the LLM to generate structured data, the LLM has conformed to our specification, right? While supplying the details of the values, this time 1, 2, 3, 4, and 5, 6, 7, 8, which it was able to extract from the user provided prompt, namely, what is 1, 2, 3, 4 times 5, 6, 7, 8? Okay, so we can see thus far, right, that having bound tools to a large language model and provided the large language model with instructions about when it ought to use the tool, and a schema about how the tool ought to be invoked, that something is happening now when we send it a prompt that uses tool use, where the LLM is providing structured data that gives us information about what tool we might call and how we might go about calling the tool. All right. Now, this might be clear, but I'd like to make it super clear. LLMs don't actually call tools. So as we just saw, our LLM is up to the task of indicating when a tool ought to be called and also of supplying arguments for how the tool ought to be called. But when we say, and this is something that you'll hear said a lot, when we say that the model is making a tool call, right, we're only indicating what just happened, right? We're not saying when it makes a tool call that it's actually invoking the tool, right? That's additional. So I'm kind of going to great length to disambiguate this because at least I found, and I found other people find it a little bit confusing when they're first learning about this. We talk about making a tool call, and we would kind of assume that that means the tool is actually being invoked or actually being called, right? But all we mean is that it's indicating a tool ought to be called or could be called and specifying how that ought to happen. Now, with that in mind, of course, we're interested in the tool actually being called. So let's look at actually calling the tools. There's a lot of ways that we could actually call the tool that the model indicates we should, and with the arguments that it supplies. And then importantly, to take the result of that actual tool invocation and give it back to the model so it can use it in its response, right? And by far the most common, and I would even say sensible way to go about doing this is with something we would call an agent. And we are going to look at agents in the next notebook. But for the time being, as you'll see when we build agents in the next notebook, LangChain is going to be doing a lot of work under the hood that's going to be hidden away from us. And with that in mind, in this notebook, we really want to spend a little bit of time here. Even though using agents is a much better approach in general, we want to spend a little bit of time here showing you how you would actually invoke tools when a model indicates that we should. So again, the process that we're going to look at in the rest of this notebook isn't exactly how we would recommend you do this in the wild. We would probably expect you to use agents instead. But by going through this process in the rest of this notebook, we hope that it makes more clear to you what's actually happening when we use agents to actually invoke tools. Okay, so let's recall that the response we got back from our prompt indicating multiplication had a tool calls property associated with it. So let's go ahead and in this case, our tool calls list only has a single value, right? Because the LLM is suggesting that we only call a single tool. Let's go ahead and get that single tool call off of there. So now we just have a dictionary called tool call that has the multiply information. And if you recall, tool call, right, contains the args here. So let's go ahead and pop those off into a variable called tool call args. And furthermore, it has a name property that has the name of the tool that actually ought to be called, right? So the value is a string and matches the name field on the tool itself. So if we look at the tool to call name, it's multiply, of course. And then we know that multiply tool has a name property. So just to confirm, it matches the multiply tool's name property. Okay. However, the tool itself, right, is not a string. We have a multiply string here, and we can't invoke this string value. So in order to get at the actual tool, we need some way to map the string name of the tool to the actual invocable tool. So for that, we're going to create a very simple mapping here. That maps the string name of a tool to the tool itself, which can be invoked. And with this map, along with the name of the tool, which we've already obtained, we can get back the actual invocable tool that we wish to call via our tool map at the key associated with the name. And we can print each of these, our tool to call, as well as back before we entered into this tool calls response from the model, the multiply tool